In this video, we're going to carry out calculations based on the chemical formulas of substances, and in particular, we're going to look at calculating the percentage mass of each element in a compound. A typical problem you might get along these lines: what is the mass percentage of the elements hydrogen and oxygen in the compound water? We can express the mass percent composition of any element A in a compound as the ratio of the mass of A over the total mass of the compound. And we multiply that by 100% to turn it into a percentage. So if we're talking about the compound water, we know that the mass of 1 mole of water is 18.02 grams, and we get that from the molar mass calculation: 2 times the molar mass of hydrogen plus 1 times the molar mass of oxygen. The contribution from hydrogen to this 18.02 figure is the 2 times the 1.08, so we can look just at the mass percentage of hydrogen and substitute it into this expression here. What we get is 2 times 1.008 grams over the 18.02 grams. Now this number here is coming directly from the periodic table, the molar mass of hydrogen expressed to 4 significant figures, and this number here is coming from the molar mass of the entire compound. When we plug those numbers into our calculator, we get 11.19% being the mass percentage of hydrogen in water. The contribution from oxygen is this 1 times 16.00. So again, we can substitute that into an expression for the mass percentage of oxygen and say that the mass percent of oxygen is 1 times 16.00 over 18.02. And again, we see that this number here is derived from the periodic table, the molar mass of oxygen to 4 significant figures, and this number here is the molar mass of the whole compound. When we plug those numbers into our calculator, we get the number 88.79%. So the mass percent of hydrogen, 11.19%, the mass percent of oxygen, 88.79%. Now that's interesting because there are actually 2 atoms of hydrogen for every 1 atom of oxygen, and yet the mass percentage of oxygen is so much higher. And of course that's because the mass of oxygen atoms is about 16 times more massive than the mass of a hydrogen atom. When we add these 2 numbers together, we get a total of 99.98%. So why isn't it 100%? And the answer just lies in some errors, particularly some rounding errors. We rounded our calculations to 4 significant figures. And we've got to remember as well that what we're dealing with here are measurements. So the reported numbers for atomic masses and molar masses are actually measurements, and they are subject to limited accuracy and limited precision. Let's have a look at another example here. What is the mass percentage of each element in the compound calcium carbonate? So the mass of 1 mole of calcium carbonate, 100.09 grams. And again, we get that from the molar mass calculation: 1 times the molar mass of calcium plus 1 times the molar mass of carbon plus 3 times the molar mass of oxygen, being 3 oxygen atoms in the formula unit for calcium carbonate. So the contribution from calcium is the 1 times 40.08, the contribution from carbon, the 1 times the 12.01, and the contribution from oxygen being the 3 times 16. So we can write these out. The mass percent of calcium is the mass of calcium over the total mass of calcium. That's the 1 times 40.08 over the 100.09, remembering that this number here we're getting from the periodic table, and this number here is the molar mass of the whole compound. And when we plug those numbers into our calculator, we get the number 40.04%. We can do the same for carbon. The mass percent of carbon is the mass of carbon over the total mass of the compound. the contribution from carbon being 1.1 times 12.01 over the total mass, 100.09 grams. Remembering again, this comes from the periodic table, and this is the molar mass of the whole compound. So again, when we plug those numbers into our calculator, we get 12.00% as the mass percentage for carbon. The mass percent for oxygen is the mass of oxygen over the total mass of the compound. The contribution from oxygen was the 3 times the 16. Now remember, we get this number 16 from the periodic table to 4 significant figures, and this number here was the molar mass of the whole compound. So again, when we plug those into our calculator, we get the number 47.96%. So we've got mass percentages for calcium, carbon and oxygen being roughly 40, 12 and 48% respectively, which comes to a total of 100%.